Hello, Hiba and Divyangi.
Yes, sir.
Good evening.
Evening.
Good evening. So, in the last class, we have discussed this part, the questions on block on another block. So, see, two blocks are, I have already explained this in the last class. So, basically, two blocks are there. This block is on this block, and a force is there on the block of having mass m1. And the coefficient of friction between this surface is mu1 and this surface is mu2, and we want to calculate the maximum force. We want to calculate the maximum force such that both blocks will move together. So if you are applying a force in this condition when two blocks are there, so there can be three conditions: either both block will be at rest, either one of the block will move, either both of the block will move together. Okay, so we will calculate the maximum force, maximum value, or maximum value of the force, so that both blocks moves together. I have told you in the last class that if you will apply the force more than a limiting value, more than a value, okay, then there will be the relative motion between m1 and m2. Means one of the block will move or another block will not move. Okay, okay. Suppose you are applying a force like this, and you have just applied a force, very large force on the mass m1. Then in that case, what will happen when you will just apply a force? This m1 will be moved, and there will be only m1 motion. Okay, motion of m1 will be there. Okay, m2 will also be moved, but if you are on m2, then it will remain at rest. But with respect to m1, m2 will also move at that time. So we can say that we want to find the maximum value of the force such that both the blocks moving together. Okay, and if we apply a force more than that value, then there will be the relative motion between the block m1 and m2. What is the meaning of the relative motion? One block is moving with respect to the another, or another block is moving with respect to one. Okay, so basically there are few steps that we have to follow. First of all, we will find the limiting friction force on both the surfaces. One surface is this, another surface is this. We will try to find out the limiting friction force. What is the limiting friction force? Limiting friction force is the normal reaction multiplied by the coefficient of static friction. Limiting friction force. So limiting friction force is, if you will calculate limiting friction force, it is given by mu s into the normal reaction. You have to see the normal reaction with respect to the surface. You have to see. Okay, if you are calculating the normal reaction with this surface or with this surface. First step. Now in the second step, search that block which has only friction force and find the maximum acceleration of this block. Basically, we will see on which of these two blocks, there is only friction force. There is only friction force, and with the help of this that friction force, we will calculate the acceleration. Okay, maximum acceleration. That acceleration will be maximum acceleration because we are interested to calculate the maximum value of the applied force. Now you have calculated the maximum acceleration. After that, what you will do? You will use this maximum acceleration in the equation of the force of other block, and you will get the value of the force F. So we will see how this is happening with the help of the question. See this question. Find the maximum value of F such that both blocks move together. One block is this, the 5 kg, 10 kg, coefficient of friction is 0.2 and here is 0 between this surface. So basically, what we have to do in this question? Okay, now see, first first step is to calculate the limiting friction force on both the block. Okay, limiting friction force we will calculate, and after that we will search for the block which have only the friction force. So one by one we will draw the free body diagram and we will check. Okay, so first I am drawing the free body diagram for 5 kg block. Okay, for 5 kg block. So this is the 5 kg block. So on this 5 kg block, the force of gravity or the weight of the block will be in downward direction. That will be for mg. Mg means 5g. Okay. Now due to this surface, there will be the normal reaction. There will be the normal reaction. Suppose this is N1. Normal reaction due to this surface. So due to this surface, there will be the normal reaction on this. Okay. Now see, you are applying a force on this block of 10 kg. So this block of 10 kg have the tendency to move in this direction, So if you will see, according to the 10 kg block means you are on the 10 kg block, and if this block has a tendency to go in this direction, then it will be look like that this 5 kg block is going in downward direction, not in the backward direction. Okay, so if the force is applied on this block, so this block will move in this direction or will try to move in this direction. So with respect to this 10 kg block, this 5 kg block will move in this direction, in the backward direction. Okay, it will be only seen when you are on 10 kg block. So that is why I am saying with respect to 10 kg block. Okay, so with respect to 10 kg block, so to this block is going in downward direction, in backward direction. So due to that, this surface opposes the motion. This surface will oppose the motion of this block and apply a force in this direction. That is limiting friction force. Friction force will be in this direction. Hiba, got it? Why the friction force I am applying in this direction?
Yes, sir.
And Dibyangi,
Yes, sir.
here is this is a tricky point. You have to understand. Basically, we are applying a force in this direction on this block. But when you will apply a force on this block, it will look like that. This 5 kg block will go in this direction. Okay, so there will be a friction force on the 5 kg block in this direction. Now after that we will draw the FBD of 10 kg. Now see for the 10 kg. First force on the 10 kg block is the weight, that is 10g. Okay, that is 10g, and this is a surface, so this here will be the normal reaction. So I am just representing the normal reaction like this. This is the normal reaction N2. Because the surfaces are different, so normal reaction will also be different. And there is a force in this direction, F. Now see here, these both surfaces, this 10 kg block and 5 kg block are in contact. So this 10 kg block has applied a normal reaction like this on the surface of 5 kg. And what I have told you, according to the Newton's third law, forces are in pair, and this 10 kg block is applying a normal reaction in this direction on the 5 kg block. So this 5 kg block will apply the same force will apply the same force N2, N1, sorry, okay, N1 in the opposite direction. Okay, so you should write N1 here and N2 here. Got it this point? Basically, this is N1 means a normal reaction by the 10 surface of 10 kg on the 5 kg surface. But in reaction, this 5 kg block will apply. So this will be basically this will be N1. Just a minute. This is N1 na? This is N1 on the block 5 kg. So in opposite direction there will be N1 like this. Okay, there will be N1 like this. Okay, and and there will be the normal reaction due to this surface on 10 kg. So that I am showing here. That is N2. Got it, Divyangi? Means how to show the forces of normal reaction.
Yes, sir.
So can you explain again?
Okay. See here. See this first 5 kg block. Okay. So this 5 kg block is drawing it again. This is the 5 kg block we have. Okay. So on this 5 kg block, there is the weight in downward direction. Okay. There is a weight in downward direction, and this 5 kg block is in contact with this 10 kg block. So basically this 10 kg block will apply a normal reaction. Suppose this is N1 on 5 kg block. Okay, and this is a force on 10 kg block. This is a force on 10 kg block. So when you will apply a force of 10 kg force on 10 kg block in this direction, so this block will be move in backward direction. It will be look like that. This block 5 kg is going in this direction. So due to that, the friction force on the 5 kg will be in this direction. Friction force on the 5 kg will be in this direction. Now 10 kg block. 10 kg block. This is the 10 kg block. So first force is 10g in downward direction. Wait, this force, I think this will be clear. Now remember, 2 points are there, very important point. First is the friction force, where the friction force will be on 10 kg, and where will be the normal reaction. What will be the normal reaction? So basically this is a 10 kg and this is the surface. So here will be another normal reaction, N2 will be there. Okay. Now this N1 is the normal reaction. N1 is the normal reaction given by the surface of 10 kg. So in the opposite direction, the surface of 5 kg, the surface of 5 kg will give the normal reaction to the 10 kg like this. Okay. N1. Now one more point, as this this is the frictionless, no? This surface is the frictionless because mu1 is 0. So this surface is the frictionless. So when this block move in this direction, there will be the no friction force on this surface. But this is a frictional surface. So when this 10 kg will move in this direction, so there will be the frictional force in this direction. There will be the frictional force in this direction, tangential to the surface. Okay. So in this direction, there will be the frictional force, and that frictional force will be again FL. Okay, that frictional force will again FL, limiting friction force. So you can see here also forces are in pair. See, this is the force of friction in this direction, this is the force of friction in this direction, this is the normal reaction in this direction, this is the normal reaction in this direction from the Newton's third law. So now see, there is no motion in this direction, there is no motion in this direction, so we can say that N1 is equal to 5g, so it will become 5 into 10, 50 Newton. So N1 is equal to 50 Newton. And what will be the limiting friction force? Mu s into n. Mu s is given as 0.2. Normal reaction is 50. So it will become 10 Newton. So basically limiting friction force is 10 Newton. Limiting friction force is 10 Newton. So here also this force will be 10 Newton because they are equal and opposite. Now, in the step, we have to first calculate the frictional force with the help of only friction force. Means we have to search for the block which have only friction force. Now see here, on this block there is only friction force if we are not considering the normal reaction and the weight. I am not talking about the vertical forces, I am talking about the horizontal forces. Okay, so see here, here is only the frictional force, but when you will see here for the 10 kg block, there is one this force and there is friction force also. So we have to search for the block which have the friction force only. So here is only the friction force, and with the help of this friction force, we will calculate the acceleration of this block. Okay, so basically, when you will calculate the maximum acceleration, why I am saying for the maximum acceleration, because here is the limiting friction force and you want the maximum value of the friction force, you want the maximum value of the friction force, that is why you have put here limiting friction force. Okay, and from the limiting friction force you will get the maximum value of the acceleration. Okay, so from here you will get the maximum value of the acceleration. So now see the total force in this direction, total force in this direction or direction of the acceleration, that is 10 Newton. So apply force is equal to mass into acceleration. So what is the force? Limiting friction force. What is mass? 5 kg. Acceleration is the maximum acceleration. So from here, this is 10. This is 5 into A max. So A max from here you will get. A max you will get as 2 meter per second square. Okay, 2 meter per second square you will get. A max is 2 meter per second square. Now we will use this maximum acceleration in the equation of force of this block. Okay, and we will get the value of this force F. Okay, now see, first we will calculate the, if you want to calculate the normal reaction here in this case, okay, then how you will calculate? There is no motion in this direction, there is no motion in this direction, so there will be the equilibrium of the forces. So you can write, see, this force is in upward direction. Okay, and these both the forces are in downward direction. So upward force is equal to the downward force, you can write. So you can write N2 is equal to N1 plus 10g. So what is the value of N1? N1 is 50 and 10g means 10 into 10, so it will be 50 plus 100, so N2 will be 150 Newton. N2 will be 150 Newton. Okay, so there is no requirement of N2 now, because we want the friction force on this surface. We have to calculate the friction force on this surface, not on this surface, because this surface is smooth, that is why there is no requirement of N2. Now we will apply this A max here. So we will use this maximum acceleration here. So what will be the equation of force? That is F minus 10 This F is acting in this direction and this 10 Newton acting in this direction. So net force on the 10 kg block will be F minus 10 is equal to mass. Mass is 10 kg and acceleration is A max we will put. So this is F, this is minus 10, this is 10 into A max is 2. So from here you will get this will become 20 plus 10. It will become 30 Newton. So maximum value of the force you will get 30 Newton. Means what does it mean? If you will apply a force greater than 30 Newton, then there will be the relative motion between the 10 kg block and the 5 kg block. Okay. And if you will apply a force less than 30 Newton, then both block will move together with the same acceleration. Okay. Okay, first note down, then we will take more questions. This is a little bit conceptual. Shiva completed.
Yes, sir.
So basically these steps you have to follow. Not in the same way, but you have to remember what you have to do basically. Okay, I'm not saying first calculate that and that, but I mean to say that you should remember what you have to do. Basically, first see on which block there is only friction force. Not talking about the normal reaction and all that. Okay, you will see only the friction force, and with the help of friction force, you will calculate the maximum value of the acceleration. Okay, by putting the limiting friction force, and after that you will use that that acceleration for the another block equation, and you will get the maximum value of the force. Okay, so write down this also. So these are a little bit conceptual question. You have to think So you have to remember these points, okay? This why this N1 and N1 are acting like this, and there is a pair of the frictional force also. Okay. So friction force also comes in pair. Any force in this world comes in pair. We will take more question, then you will understand more. Hiba, complete it.
Yes, sir.
Okay, so now see this when complete first this part, then we will see. Okay, now see this. Basically, what I want to say, uh, this is the. Hmm, hmm. See, this is the surface. Sorry, this is the surface. Okay, this is the surface, and this is the one block, and this is another block. This is the surface. This is one block, and this is another block. So what I am doing, first I am applying a force on this. So I have applied a force. So now you can see neither of the blocks. This is a copy, I know, but consider this is a book, I know, but consider these things as block, and this is as a surface. Okay, this as a surface. This. Okay. So I am applying a force. Neither of the blocks, this or this, is moving. So now I have applied a force. Now you can see both are moving. Both blocks are moving. You can see here. I have applied a force like this. Both are moving. But there will be a force when I will apply that force, the magnitude of that force. In that case, what will happen? This block will move and this block will be at rest. Okay. Okay. But I cannot show that here, but you have to understand what I want to say. There will be the that value of the force. Suppose I have applied a 10 Newton. So both are moving together. Suppose I have applied 15 Newton, then also both are moving together. Suppose I have applied 100 Newton. In that case, what will happen? There will be a motion like this motion. This type of motion will be there. There will be the relative motion between the block. So now what we are discussing, we are calculating that maximum value of the force for which two blocks will move together with same acceleration. With same acceleration, two blocks will move together. If we exceed the value of that maximum force, then this will be the condition that I have shown you, like this. Okay, means this block will move like this. You can see, means there will be a relative motion between the two blocks. Okay, so this can be the condition. It is very difficult to show here like this. Okay, so maybe I don't know whether you have understood or not. Okay, so we will solve that question. So basically, if I will apply a force more than 30 Newton in this case, then what will happen? There will be the relative motion between 5 kg and 10 kg. If I am applying a force of 25 kg, then both blocks will move together with same acceleration. Okay, so this question now I am taking. So you can see earlier the force was on 10 kg block. Was on 10 kg block. Now we are applying a force of F on 5 kg block basically, and this is a frictionless surface, and this is a frictional surface having the coefficient of friction 0.2. In this case, we want to find the maximum value of the F such that both the blocks will move together. So now what we are doing? We have this system. What we are doing now? We are just applying a force on this upper block so that both the block will move together, this and this. Okay, so same things we will do. First we will see the block on which there is only friction force, and we will calculate with the help of that friction force the maximum acceleration, and we will use that maximum acceleration in the equation of the other block. So first I am just drawing the free body diagram for 5 kg block. So see this 5 kg block. So this is a 5 kg block. Okay, on this 5 kg block there will be the weight of the block 5g, and there will be the normal reaction n1 on the 5 kg block n1 due to the surface of this 10 kg. Okay, due to the surface of this 10 kg, and a force F in this direction. Now see, there is a force on this block in this direction, so there will be the friction force on the surface in the opposite direction of the applied force, because this block have the tendency to move in this direction, or in the direction of the force. So basically here will be the friction force in this direction. So in this direction there will be the friction force, limiting friction force will be there, because we want to find the maximum value of the force we will get when we will put here the limiting friction force. Now n1 we can find easily. N1 is equal to 5g, as there is no motion in the vertical direction. N1 is equal to 5g. 5g means 50 Newton. Okay, friction force we can find, limiting friction force, mu s into n. What is the value of mu s? 0.2. Normal reaction is 50, so it will become 10 Newton. So basically this force will become 10 Newton. 10 Newton force. Now for 10 kg block. This is a 10 kg block. First force on the 10 kg block will be its weight in downward direction like this. This is 10g, and normal reaction due to this surface on 10 kg. Suppose this normal reaction will be different. Suppose this is N2. Now N1 will be like this also. N1 N1 will be the normal reaction on the 10 kg block due to 5 kg. Okay. Now any other force? Now friction is acting in this direction on the 5 kg block. Now see here, uh, force is applied here in this direction. So this 5 kg block has the tendency to move in this direction. So when you will, with respect to this 5 kg block, this 10 kg block will go in this direction. So friction of on 10 kg will be in this direction. In this direction, remember. So on 10 kg block, the friction will be in this direction, limiting friction force, and the value of that limiting friction force is 10 Newton. 10 Newton. Now we have to search for the block having only friction force. So here is one friction force and here is one applied force also. But here is only friction force. Okay. Not considering the vertical forces, I am again telling again and again. Okay. So basically now with the help of this friction force, so we will calculate the maximum acceleration of this block. So force is equal to mass into acceleration. So here is only one force. Okay. That is equal to FL. Mass is 10 kg. Acceleration maximum we want to find. What is this FL? Is 10 Newton. So put this 10 is equal to 10 into A max. So A max we will get 1 meter per second square. 1 meter per second square. Now we want to find the maximum value of this force. So from 5 kg block, from 5 kg block we will use this maximum acceleration here. So see it as a, this block is moving in this direction with an acceleration of 1 meter per second square and force on the block F and 10 Newton. So what will be the equation? F minus 10 is equal to ma. F minus 10 is equal to mass into maximum acceleration. So F minus 10 is equal to, what is mass? 5 kg, maximum acceleration is 1. So F is equal to 50 Newton. And this F will be the maximum force. Maximum force up to which both the blocks will move together. Okay, so you can write here maximum force up to which both blocks move together. Okay, so clear, Divyangi and Hiba, how to calculate the maximum force in these types of question?
Yes, sir.
Okay, so write down. this acceleration is not the actual acceleration. Okay, this will be the acceleration when there will be the maximum value of the force. We are just calculating the limiting values. Completed, Hiba and Divyangi?
Yes, sir.
Hiba, completed?
So one sir.
Okay. Now we will take a question like this, but there will be slight change. There we have to apply this concept first.
Done sir.
Okay. So now basically na, this force 50 Newton means 50 Newton. What is the meaning of this 50 Newton? Okay. Meaning of this, suppose you have these two blocks. Suppose you have these two blocks, and if you are applying a force of 20 Newton, 20 Newton you are applying means your applied force is greater than the maximum value of the force. What is the value maximum force we have got for this case? 15 Newton we got. If that value is greater, applied force is greater, then there will be the relative motion that I have shown. Okay, this block will move alone. But if suppose the value of the force is, suppose the value of the force is, you can write this here, applied forces. If the value of the force, applied force, is less than the maximum value of the force. Suppose you have applied a force of, suppose F applied is 8 Newton. F applied is 8 Newton. Okay. And what is F max? F max is 15 Newton. So in that case, what will happen? Both these blocks will move together. Both these blocks will move together, na? So both these blocks will move together with the same acceleration. So next question will be based on this concept. First, you have to check whether whether both the blocks will move together, okay, or not. So for that, you have to first calculate the maximum force and see what is the applied force. If the applied force is greater than the maximum force, then you can say there will be the relative motion, or one block will move alone. There will be no means both the block will not move together. If maximum value of the force is greater than the applied force, then in that case you can say both blocks will move together. Both blocks will move together, and there will be the common acceleration also. So now see this question. Huh. This will be the case. This can be the case. I will tell you. Basically, the next question is like that also. So you can understand what will happen when no blocks will move. No zero acceleration. So see this question. This is the question. find the acceleration of both the blocks. This is the question. Find the acceleration of both blocks. Okay. Okay, and 10 Newton they are applying. So in this case, what you will do? First, you will find the value of the maximum force that can be applied on the block so that both block will move together. So now see here, in this case, this is the applied force. Applied force is, so we have this calculated now, 15 Newton for the same question I have taken. Okay, so 15 Newton was the maximum value of the force. Okay, now we are applying a 10 Newton. We are applying a 10 Newton. So applied force is 10 Newton. Now you can see here the maximum value of the force is greater than the applied force. So what will happen, Divyangi?
Both blocks will move together.
Yeah. You were asking that what will happen when both blocks will not move. This will be the possibility. Why? That can be the possibility when this is also the friction. This surface also have some friction. Okay, because this surface is smooth. That is why you are applying a force. There is no opposing force. There is no opposing force. That is this. That is why this system is moving. Okay, so you can say that both blocks will move together. Both blocks move together. Hiva, are you getting? And Dipyangi?
Yes, sir.
This maximum value of the force you have to calculate in the examination. Okay? Because if it is given in the question, then it's okay. Otherwise, you have to calculate with this method that I have told you. Okay? Then you will see whether both the blocks are moving together or not. For time saving, I am writing directly. Okay. So now you have to calculate. Now it is known that both the blocks will move together, and both blocks now moving together. And in this case, we want to find the acceleration. We want to find the acceleration. So how can we find the acceleration? Just tell me the answer. Try this by yourself. Consider this whole as a system. The system is moving with an acceleration, and that acceleration system have the acceleration a. So acceleration is equal to net force divided by net mass. What is net force? 10 Newton. Net mass is 15. So answer will be 2 by 3 meter per second square. And you can also solve this question by drawing the FBD and all that. Okay. So write down. One more question I want to ask you, Hiba. What will be the friction force here? In this case, when both these blocks are moving together. Okay, write down, no problem. Divyangi, on this block of 5 kg, which type of friction will be there?
10 Newton.
Right
That
answer. Because with respect to this 10 kg, this 5 kg will be at rest. Both are moving together. So there will be the static friction. Why? Because there is no relative motion between such surfaces. Okay. That is why the friction force will be 10 Newton. Completed? Both of you?
Yes, sir.
yes, sir.
So if you have any doubt, then you can ask me. Time is over now. Okay. So we will meet in the next class.